Yeah, so the title of my talk is Carbon Friendly Forests and Forestry. And really, I want to try to make sense of a very complicated field that's developed over the last decade or so. There's so much that one needs to know in order to understand not just the basics of carbon silviculture and carbon forestry, but also the rapidly developing carbon markets and the sort of international and global interest around natural climate solutions. And there's so much detail and so much richness to this topic that it's become almost impossible to cover this well in an hour. But I'm going to do my best. I'm going to try to give you some of the basics, and then if there's anything that you're still confused about afterwards, and I'm sure there will be, anyone should just feel free to drop me an email or contact me later on. Okay, so let's get into this. And we'll move along here. Yes, so you will hear people talking about a lot of different approaches that we might take to manage forests for climate mitigation and climate benefits. And there are debates swirling around our region and other parts of the world as to the best approach. We're going to cover several of the approaches that are on the table. But I would like you to take home from this talk one central message, which is that there really is no single approach that we should be taking for managing forests for carbon storage and sequestration. Rather, we should be thinking about this as a portfolio of carbon forestry options that we have at our disposal. There are a variety of different techniques and approaches that we might use. Each of those has different carbon and climate benefits and a different mix of co-benefits. And so just as is true of sustainable forest management in general, we're really talking about this concept of risk spreading, which put very simply just means not putting all of our eggs in one basket. Anything that we do carries risk, carries uncertainty. There are things that we don't know. There are things that will change into the future with climate, with invasive species, with other symptoms of global change. And so best to spread the risk and to try different things and to think of carbon forestry again as a portfolio. That concept, by the way, was articulated by David Lindenmayer and Jerry Franklin in a very famous book that they published almost 20 years ago now. Okay, so I think that this idea of a portfolio really underlies many of the natural climate solutions studies that have come out recently. I'm sure many people on the call have followed these. These are really high impact papers, often led by scientists at the Nature Conservancy, their carbon team, in Arlington, Virginia, but usually involving scientists from all over the continent, all over the world. And we have papers like this now for the globe, for the US specifically. That's the one you're seeing here. And just in the last year, we published one covering Canada as well. So, these papers all share a similar approach, which is to essentially attempt to quantify the climate benefits from the full array of land management options that we have at our disposal. So everything from the various different forest sector approaches, reforestation, improved forest management, avoided forest conversion, fuels management and fire restoration in fire-prone forests, et cetera, to the full array of approaches that we might take in other types of systems as well, both agricultural and natural. And most of the studies look kind of like this in that, they help us understand the mitigation potential of various different natural climate solutions. They help us understand the costs associated with them. The colors that you're seeing on the bars here represent different discount rates. So it's a way of thinking about kind of the low-hanging fruit, things that we could do relatively inexpensively in the near term, and then things that would be more expensive that would probably take us longer to phase in that we could also think about. In any case, in almost every one of these papers, including this one for the US, the forest sector wins out as one of the greatest potential natural climate solutions. But again, it's not just one thing. It's not just passive reserves in wilderness areas. It's not just fire restoration. It's not just reforestation. It's this portfolio that we need to think about and that we have at our disposal. Okay, so let's try to make sense of those different natural climate solutions and this portfolio a little bit better. One of the things that trips up this conversation and trips up this debate over and over and over again, you see this rearing its ugly head, so to speak, is a confusion and a misunderstanding of sort of basic concepts of carbon cycling. And so I'm going to try to boil it down to the crux of the debate, the two things that you need to understand in order to do the full calculus, the full carbon accounting, to understand the net carbon benefits of any particular option in our portfolio. Okay, so it comes down to this. When people talk about sequestration, what they really mean is carbon uptake through the process of photosynthesis, right? We all know that this is a very important ecosystem service that vegetation performs for us. And when it comes to forest, that service, uptake, sequestration, is at the highest rate in younger, rapidly growing forests that you're seeing here on this part of the curve. But over time, as forests develop, as they mature, as they accrue and accumulate biomass both above ground and below ground, and if we're in a moist, temperate forest ecosystem like we have here with a lot of precipitation, what we also see is this above ground complexity, architectural or structural complexity that develops late in succession. All of that represents the work of sequestration past, right? It's like the sequestration that the forests have already done for us over preceding decades and centuries. And so that's why in older, more complex forests, we see the greatest levels of carbon storage. So understanding sequestration and storage are both, it's important to understand both of those, and we have to put all of that together when we do the carbon accounting. Okay, this is going to come into play now as we look at different carbon portfolio options, now that we understand the basic difference between sequestration and storage. It's really very key. Okay, so in this world of carbon forestry, there are generally three different categories of options that we can think about. So the first one is this: avoided deforestation, which in some cases can include passive management, such as wilderness area designation or strictly protected biological preserves. It might include other types of conservation approaches for high conservation value forests or indigenous lands and a whole variety of things. Let's take a look at this particular carbon forestry option, and we'll break it down into its two component parts: the avoided deforestation part and this passive management, which is somewhat synonymous with, let's say, wildlands or old forest management, those sorts of things. Okay, so we'll start with avoided deforestation. So this basically means avoiding the conversion of forest to other land uses like agriculture or housing or impervious surfaces or just about anything, and avoiding the flux to the atmosphere that would happen if we clear forests and convert them to another land use. Now, for a long time, we've known that simply conserving forests, like keeping forests as forests, was probably the single greatest thing we could do for the climate. But very recently, we've had a flurry of really excellent studies that have quantified now, really for the first time, the carbon and climate benefits of avoided deforestation in our region. This is a report that just came out a couple of months ago. Very exciting. put together by researchers at Clark University, Chris Williams and his colleagues, working very closely with the Nature Conservancy and others. And it provides, for the first time, a really detailed analysis of the avoided deforestation benefits from a climate perspective for New England and New York. So I'll just try to walk you through this exercise that they performed, and we'll do that using a series of maps. Okay, so we'll start here. So this is a layer showing the above ground carbon stocks or biomass in forests and vegetation across the Northeast. And you're seeing that varies, and you can see this, correlation with less fragmented, better conserved landscapes like the Adirondacks, like the Catskills, like the Green Mountains and the Berkshires, etc. Okay, so then we can quantify, or we can map forest conversion over the last decade, and we can see, actually this was the previous decade, 2000 to 2009, and we can see where forest conversion is happening the most. We can quantify the direct emissions from that conversion. So this is the flux from forest vegetation that's removed from the land, the flux of carbon that was stored in the vegetation, and also to some degree flux of carbon that was stored in the soil and below ground. We can also quantify the foregone sequestration potential. So here you're seeing storage quantified in the previous map, and then sequestration quantified in this one. So this is like the opportunity cost, right? Like the missed future sequestration potential of the forests that we've cleared or converted to other land uses. And then we can put that together and we can estimate this total carbon emission burden of both the initial carbon flux, the loss of storage, so to speak, as well as the foregone sequestration potential. And then now the final map is where it gets really exciting. We can then, really attach a price tag to some of this. We can say, all right, well, we know both where land use conversions are happening, we know where forests store the most carbon, and we can then map and quantify the areas throughout our region that have the greatest climate mitigation benefits, and where conserving forests would give us the greatest bang for our buck in terms of climate benefits. So that's what you're seeing here, an estimate of the price per metric ton of carbon dioxide equivalents for conserving forests. Okay, so Vermont shows up pretty clearly here, as does northern New York and northern New England, as a place that has the potential to provide really significant climate mitigation benefits at a lower cost, at least from a regional perspective, in comparison to southern New England, from a carbon standpoint. Okay, so we now have a much better understanding of avoided deforestation as one of these carbon portfolio options. All right, now let's get into the other component of that first category we're talking about. Remember, we're talking about avoided deforestation and passive management. Okay, so there's a movement afoot in New England. You've probably heard people talking about this. This is something that has been around for a long time. Since the early 1990s, we've been talking about this, but recently the term was coined proforestation. So people are using that term now to talk about this. And it's the idea that, there could be carbon and climate benefits from strictly conserving forests, passively manage them, and allowing them to grow into an older forest condition. Okay, so that's the option that's on the table. So let's look at that a little bit, because again, there is debate around this question and how well it would work. Okay, so this is an area that I've worked in for most of my career. I've studied old growth forests all over the place. And I often use this slide. This is a nice one. It came out in this very famous paper about 12 or 13 years ago that reviewed carbon flux studies from all over the world. That's what these data points are here, from about 500 forests, both temperate and boreal, and plotted that along this axis here of forest age. shown here is something called net ecosystem productivity, which is basically the net carbon that's added to an ecosystem after you've accounted for respiration by plants, as well as carbon loss through respiration by heterotrophs, by consumers like us. Okay, and so if you're above this zero line, it basically means the forest is adding more carbon than it's losing. Okay, so this paper came out and it generated a lot of interest. People were very excited. But then questions were raised. For example, doesn't it kind of seem like we're comparing apples and oranges by comparing all of these different forests from all over the world and just kind of lumping them together on the same axis? That's a very legitimate criticism. I mean, coastal redwood forests out here in California are completely different from, let's say, Norway spruce plantation in Sweden or something like that, right? So forests perform relative to age very differently depending on where you are in the world and what the soils are like, what the site characteristics are like, all kinds of things, right? Okay, so that was a legitimate criticism. And then just recently, about last January, actually, this very critical kind of reanalysis of the data set was published and generated, what I would really describe as a pushback on this concept and kind of generated its own flurry of press articles. Old growth forest carbon sinks are overestimated, blah, blah, blah. Okay, so this article pointed out some of the criticisms I just mentioned. But, in turn, we could now criticize this reanalysis, as I will right now. This was led by a team at the University of Copenhagen. They were mostly working with Danish beech forests, and they were basing a lot of their conclusions on beech forests in Northern Europe. And, I could point out many flaws in that approach, and I don't think it's a full rejection of the carbon storage potential of older forests in other parts of the world. Okay, so the jury's still out a little bit on this question. Suffice it to say, though, there is quite a bit of debate. So when you hear someone making a pro-forestation argument, listen, acknowledge, but understand that there is a scientific debate happening around some of these concepts. But let's look at the Northeast specifically. Okay, so this is some of my own work, working in northern hardwood forests and kind of mixed conifer, like hemlock hardwood systems, mostly in the Adirondacks, but also White Mountains and Maine and elsewhere. What we've learned about carbon sequestration and storage relative to age in northern New England and New York is that there are a variety of pathways along which this can play out over time. In some cases, we do see this sustained long-term accumulation of above-ground biomass and carbon storage, just as that Louisiart et al. Study predicted. But in other cases, we might see more of these shifting gap equilibrium dynamics that were proposed long ago at Hubbard Brook. And still in other places, like the C and D line here, as measured at Hubbard Brook, we might see very early declines actually in biomass accumulation. But we now know that those can be attributed mostly to acid deposition and calcium depletion from soils and plant tissue, which reduces the productivity of the ecosystem. The D line, is the reversal of that decline through aerial calcium additions that has been tried experimentally at the Hubbard Brook Experimental Forest in New Hampshire. Okay, so the take home here is that there are a variety of pathways along which biomass accumulation can play out over time in our forests right here. Primary forests, old growth forests, forests that we might expect to see develop over centuries in wilderness areas, show this kind of dynamic in the bottom figure. Non-equilibrium dynamics characterized by periods of growth and development, followed by carbon fluxes resulting from partial disturbances like ice storms, microbursts, insect outbreaks, pathogens, and then biomass recovery. So these are the dynamics that we now know play out in primary forests, old growth forests that have never been cleared before. And what that means from a carbon standpoint is that even though carbon is in flux in these forests, it's constantly oscillating up and down over the very long term, those forests nevertheless maintain higher carbon stocking on the whole as compared to a landscape that's managed much more intensively for timber, let's say using more intensive silvicultural practices or shorter rotations. The net effect of a landscape like that is lower carbon stocking. So even with these different pathways that we now understand and these dynamics that we now understand, a wild or a primary forest landscape is likely to have higher net carbon storage than a more intensively managed landscape. Okay, so that supports the proforestation argument to some degree. But again, it's complicated. There are uncertainties here, and there are nuances that we need to understand. Okay, so that was a long explanation of the first category. Let's go on to the next one. And by the way, Jens, I can't see the chat board here, so if anybody has questions and you want to interrupt me, please just let me know, okay? All right, so next category, and probably the easiest to understand from a carbon standpoint is this one, reforestation and afforestation, which basically means planting trees where there have never been trees before, which carries its own trade-offs in terms of biodiversity and, you know, converting one habitat type to another habitat type. In this region, reforestation, afforestation is an important option. It's something that there's a lot of potential for, particularly in riparian buffer restoration projects like those that we're doing very actively all over the Lake Champlain Basin. But there's probably less potential from a carbon standpoint for this than in other parts of the world where there has been more deforestation and maybe where there's less forest cover. But still an important one to think about here. Okay, the last category, and actually probably the hardest to understand from a carbon standpoint, and yet the one where there is the most activity on the carbon markets. And I'm going to argue where there's probably the greatest potential actually for working forests in a state like Vermont. It's this one, what we call improved forest management. Okay, so the bottom line with this is making a substantive change in the way you manage your forests such that you add some margin of carbon storage over time above and beyond what otherwise would have happened. So you can't just follow business as usual. You have to make a change. You have to improve the way you're managing your forests. But again, the carbon portfolio, we have a lot of different options at our disposal. And we could just quickly run through some of those. They include a whole variety of different retention forestry practices that many landowners all over the eastern U.S. are now trying or using routinely, like irregular shelterwood systems, a variety of group selection with retention systems, dispersed retention like you're seeing here in this red pine stand in Minnesota. There are a whole variety of retention-based approaches that we might think about. Here's the gap harvesting or group selection harvesting with some degree of permanent long-term legacy tree retention. This is what some have called the expanding gap system or the Acadian Femmelschlag, first pioneered at the University of Maine, Penobscot Experimental Forest there, and that we now see being used really all over the region. They also include an approach that I've tested here in Vermont called structural complexity enhancement, where we're using active silvicultural treatments to deliberately restore and promote the development of old growth forest characteristics over time. Turns out that has a real carbon benefit as well. Okay, so bottom line, we have a whole variety of different silvicultural techniques that we could use for improved forest management in our region. Let me just walk you through some of the science behind this really quickly. And I did want to cover this because this is a study or a paper that Jared Nunnery, a former graduate student, and I published 11 years ago that is frequently mentioned in talks that are given around the region as supporting one view or another. And I'm going to share with you that I feel that the study is often misrepresented or characterized in an overly simplistic way, not recognizing all of the various qualifiers and caveats that were in the paper and the uncertainties that were present at that time that this was published more than 10 years ago. And so let's make sure we understand what we can take away from this study, okay? So in this study, this is Jared Nunnery and Bill Keeton, 2010, we modeled 9 different management scenarios for northern hardwood forests in the Northeast. These included 8 active management scenarios, including some of these retention-based systems that I just mentioned, as well as a baseline no management scenario. That's the 9th scenario that we modeled. So remembering that this was actually, the research, the modeling work behind the study was conducted way back in 2008. At that time, these models that we're using were relatively primitive. The models didn't capture natural disturbances. They didn't capture climate change. They didn't give us a way to predict invasive species movement, loss of foundation species like eastern hemlock or, American beech, or even potentially sugar maple if we have, a significant expansion of, Asian longhorn beetle, for example. So there were a lot of limitations in the modeling that we could do back then. And moreover, the no management baseline that we modeled that you're seeing here, the carbon accumulation over time through passive management, and this line that you're seeing right here is held up over and over and over again by people sort of touting the carbon benefits of wildland conservation. This was used for comparative purposes in this study as a baseline to compare against. Not saying that it's not real. I'm not saying that there aren't real carbon benefits through wilderness conservation. There are, and we just talked about those and some of the dynamics that we need to understand. But in this study, it was used for comparative purposes and carried a lot of uncertainties that I've just listed for you right here. Okay, so now you understand some of the finer points. And now I'm going to walk you up through these management scenarios. So we'll start with the most intensive scenario here at the bottom. This is clear cutting on short rotations. And on the y-axis, if you can see it, we have the total carbon storage associated with each of these management scenarios. So that includes all the carbon that's stored in the forest over the long term, as well as carbon that is harvested and transferred into wood products and that has a certain residency time in those wood products. It has a life cycle in wood products before the carbon dissipates and fluxes back to the atmosphere, because products are disposed of and landfilled or incinerated or something else. Okay, and then as we walk up through these scenarios, and we're reducing management intensity as we do so. So harvest intensity is declining. We are retaining more structure. We're harvesting less frequently. We're walking up from the most intensive scenario to the least intensive scenario. What you're seeing is that the average net carbon storage increases as we reduce management intensity. And that's both through retention of carbon storage in the forest, as well as the amount of carbon that is stored in wood products. Okay, so we can make sense of it here on this figure. So we've arrayed all 9 of those scenarios along this continuum from most intensive management scenario to least intensive management scenario, including passive management or full conservation over here on the right. And then we're seeing the average amount of carbon that's stored over 160 years, basically 2 rotations of sugar maple, both in the forest as well as in wood products. And the take home from this paper, the message that we tried to communicate, was not that you necessarily have to stop managing forests. That, of course, is a potential in some places where we're interested in establishing wildland preserves. So again, that is a very important, very viable, beneficial option in our portfolio, but it's not the only option. We can also accrue carbon benefits by making adjustments in our management, by shifting from a somewhat more intensive scenario to a slightly less intensive management scenario. And in doing so, we accrue this margin of enhanced carbon storage. And that's what carbon markets call improved forest management. That's what carbon markets reward you for through carbon emission offsets or carbon credits. Okay, so that was a long explanation of improved forest management, just because it's such an important one. And again, it's important to understand the various different options that we have. Okay, these days, there's another one, another option that we should consider here that's generating a lot of interest. You've heard this probably described as mass timber or large timber frame structures that there's a lot of interest in building now all over the world through the use of sort of large dimension timber framing products, including composite beams and other types of materials that, like you're seeing here in these pictures. And the idea is that by building mass timber structures, we could potentially store a lot of carbon in those as an important carbon sink as well. Okay, so let's pull this apart a little bit. So what about durable wood products and what people are now calling substitution effects? Okay, so let's try to understand substitution effects and what that means, because substitution effects are the crux of the mass timber argument. Okay, this is the way it plays out. So everyone on this call probably knows that wood products have a much lower carbon footprint associated with their production than does other types of building materials like concrete, steel, plastics, and various different composites. Timber has some, carbon footprint for sure. There's all the management activity that happens in a forest over time. There are the emissions from harvesting and transport and processing of wood products. But in comparison to the enormous amount of energy that is needed for the production of concrete and steel, the emission profile is a lot lower. Okay, so that's what you're seeing here in this figure. The idea with substitution benefits is that if we were to use timber in place of concrete and steel and other materials that have a high carbon footprint, every time we do that, every time we use wood, we're avoiding emissions that otherwise would have happened. So it's another substitution effects are another type of avoided emission, basically. So let's look at that here in this figure. Here we have sort of a typical selection harvesting management system for northern hardwoods. We have a forest that's growing and developing and it's adding carbon. We have a thin, we have another thin later. Then we have a regeneration harvest, maybe with some retention here, and then the forest regrows. Every time there's a commercial harvest, some amount of that carbon is transferred into wood products, where it then has a life cycle or residency period before fluxing back to the atmosphere. Okay, so we can add wood products carbon to the carbon that's stored in the forest. If we think about avoided emissions from using wood products, we can quantify that up here. So these are the emissions that we're avoiding by not producing or not using concrete and steel. And from that standpoint, these substitution effects start looking really good. They start really adding up over time. And at a certain point, the sort of total substitution benefit actually exceeds what a no management scenario might have yielded. Okay, so this is what gets the forest products industry very excited, and a lot of others really excited as well. Okay, so this is something we need to take seriously, and there are probably some real carbon benefits from mass timber and from, you know, these avoided emissions. Okay, but just as with all carbon science, it's just not that easy. It turns out that there are a lot of some assumptions that go into that kind of an analysis. Like, for example, that all forests are going to perform the same in terms of the substitution benefits that their wood products produce. And that's just not the case. Substitution benefits will vary dramatically depending on the forest type and the management regime that are at stake. There are also a lot of assumptions about how markets will respond in the future if we start producing a lot more timber, right? We all have these there are always these supply and demand curves that we all learned about in microeconomics that are at play, and there's, you know, the potential for a market to sort of down-regulate the demand for timber in the future if we're producing more than the market can absorb, or if you know, costs increase. So there are a whole variety of market forces at play that make some of the very, very rosy projections around substitution effects a little bit uncertain. Okay, so suffice it to say, there's a lot of uncertainty in this particular debate as well. But again, another thing we need to add to the portfolio and we need to think about as part of the overall risk. Don't put all your eggs in one basket. Let's use a variety of different approaches. Okay, so that was a very lengthy overview of carbon forestry and those three broad categories that we can think about. Really quickly, let's just summarize some of the co-benefits. Like, what are the other benefits that would accrue if we start using this kind of carbon forestry on the landscape? And these are really important, by the way, from a market standpoint. The forest carbon projects that perform the best on the market, that are able to gain the highest price point or premium on the credits or the offsets that they sell, are the ones that typically have the highest co-benefits. And that's because the buyers of carbon credits, wherever they are in the world, want more than just the climate benefit. They want to know where the credits came from. They want to know something about the landscape that the carbon project helped conserve. They want to know if important wildlife habitats were protected and other kinds of amenities that the carbon projects are providing. Those are the projects that generate the highest price points. Okay, so we really need to be thinking about co-benefits then as we do carbon forestry. Dominic, Tom, and I published a paper just a couple years ago showing that, just as an example, by the way, that National Audubon Society's forestry with birds in mind, or silviculture with birds in mind, could have real carbon benefits as well. So I'm kind of reversing the co-benefit question. Let me just flip that on its head. If we use carbon forestry to promote bird habitat, as we're basically doing in Audubon silviculture with birds in mind, so we're promoting structures that a variety of different bird species need, that's also likely to have real carbon benefits. That's what we showed in this paper. So kind of merging forestry for the birds with carbon forestry. The H index is a measure of structural complexity. So basically the story here is, if we manage forests for greater complexity, trying to favor a variety of different bird habitats, we're also going to store more carbon on the landscape. So just a different way of thinking about co-benefits. We got birds, we got carbon in this case. Okay, what about some other co-benefits? Well, from a conservation standpoint, we all know that we need to be thinking about reversing these kinds of trends that you're seeing right here. These are the trends in forest cover across the 6 New England states that were described in the Wildlands and Woodlands report about a decade ago. We all know that for the first time in 150 years, all 6 states, including Vermont, are now losing more forest cover than they are redeveloping. And this is entirely an artifact or caused by suburban and exurban development. So land use conversions for housing, through parcelization, through subdivision. It's the footprint of that sort of perforated canopy that's spreading across our landscape, the fragmentation effects. And so what we're looking for these days is sort of every incentive in the book that we can throw at this problem to help keep forests as forests, to help landowners conserve and maintain their forests as working forests, as wildland forests, as a whole variety of different types of forest uses. Okay, so we're thinking about now these forest blocks that have been mapped statewide, and you know whether we could use carbon projects as a way to help promote the conservation of some of these forest blocks and maybe even buffer them and reestablish larger, more contiguous areas of interior unfragmented forest cover. Okay, so conservation of unfragmented forests is one potential co-benefit of carbon forestry that we'll look at in just a second, where I show you a study where we actually did that. Another really important co-benefit that we need to be thinking about these days in New England is flood resilience, especially kind of in the wake of Tropical Storm Irene, 2012. You know, the flood resilience service that forests provide has assumed a much higher profile. We all know that that's really important now, and everyone on the call probably knows that forests are not all equal in terms of the flood resilience benefits that they provide. Certainly, floodplain and riparian forests are very important from a flood resilience standpoint, but in some cases, it turns out that upland forests are very important for hydrologic regulation in a variety of ways also. So we need to be thinking about these flood resilience benefits of forests, and maybe that's something that we can provide through carbon forestry as well. And again, I'm going to show you a study where we actually mapped and quantified that co-benefit as well. Okay, I'm going to put all this together, all these co-benefits together now through the final part of the talk in my last 10 minutes, which is this, where we talk about opportunities for landowners in Vermont and the Northeast in general, that would include both sale of carbon credits, but also generation of these co-benefits that we're interested in. So now I'm going to be presenting work that is really a large team effort that my lab, the Carbon Dynamics Lab at UVM, has done, working closely with Vermont Land Trust, with the Nature Conservancy, with a consulting group called Spatial Informatics Group, with a regional conservation initiative called Cold Hollow to Canada in northern Vermont around the Jay Peak area, and with very generous funding that we appreciate from VHCB and from the High Meadows Fund. This project has gone through a number of phases. The first one was this feasibility study that we published a few years ago, where we looked at the potential for forest carbon projects across Vermont. And we tried to understand the best opportunities for landowners. What are the best market opportunities that a landscape like ours could take advantage of? And by that I mean, relatively small parcel size, mostly privately owned, landowners that are interested in a whole variety of benefits and amenities from their land, of which timber is one but not the only. Okay, so what's the best pathway for a state like ours? And we also wanted to understand co-benefits. Okay, so we looked at the major market systems that are out there, and I'm going to have to move quickly through this because I'm really behind time and burning up a lot of time here. But I'm assuming that most people on the call know that there are two fundamental types of carbon markets that we now have in the U.S., across North America generally, and globally. These are the international voluntary market, which basically is synonymous with over-the-counter. It means you have a project developer, could be forestry, could be renewable energy, could be something else. In one part of the world, they're generating emissions offsets, and those can be sold more or less directly to a buyer somewhere else in the world that has an interest in reducing their emissions for whatever reason. It could be a government, it could be an institution, it could be an industry. The other type of market is the compliance market, also called regulated or cap and trade, like the California carbon market, like the market in British Columbia, like the market that Quebec now has, and like RGGI, although RGGI is more limited when it comes to the forest sector. That's the Regional Greenhouse Gas Initiative. So cap and trade is really different. It's regulatory, it's mandatory. It means a state, a region, a country, a continent like Europe sets a total emissions limit, that's the cap, and then the regulated sectors that are included have to ratchet down their emissions over time to meet that cap. And then furthermore, the total cap itself is ratcheted down year by year in order to meet an objective, like 1990 emissions by the year 2030, or et cetera, et cetera. Okay, so that's the way cap and trade works. So thinking about a state like Vermont, both markets provide some opportunities. There are parcels, there are landowners here in Vermont that certainly could think about enrolling carbon projects in a compliance market, basically selling the offsets into the California market, even potentially in the future selling to Quebec or British Columbia, if that becomes an option, or hopefully selling into the New England RGGI system if we can expand forest sector participation in that. But it turns out that that's really only going to work well here for the largest properties, those that are maybe about 1,500 acres or more in size. And that's because there are real economies of scale at play here. And let me explain that. The transaction costs of developing a carbon project, the expenses are formidable. And it turns out that you need enough of a land base, enough of an area to generate enough revenue to exceed those very high transaction costs. And that's why, because of these economies of scale, really only the larger properties will be financially viable under these compliance market systems, at least now as the way things stand right now. The benefits, though, are that there's a higher price point in these markets and some other things, but also a much longer contract period that gives some landowners second thoughts. So what that means is that probably by and large, the lion's share of the opportunities in Vermont will be here in the voluntary market. And that's because, I'm going to skip this because I'm running out of time, and that's because the voluntary market provides the opportunity for something called aggregation. It allows landowners to pool together multiple smaller properties, forming larger aggregated carbon projects that can gain these economies of scale that are needed for a project to be financially viable. Okay, so that's what you're seeing here in this diagram that was in the feasibility study, where we tried to understand these different pathways that landowners in Vermont could consider. There's the compliance market pathway and all of the things a landowner would need to think about to be eligible for that, like certification, How would you integrate conservation easements? What kind of management plan would you need, et cetera, et cetera? How could you take advantage of cost share programs? So certainly an option for some landowners, but probably only the larger parcels. The most viable pathway is here under the the voluntary market, again, because aggregation is possible. And then the savvy landowners will think about how they can put all these other forest stewardship mechanisms together with carbon in order to generate the greatest financial viability for their properties. So, enrollment and current use value appraisal, acquisition of conservation easements, certification under Forest Stewardship Council, American Tree Farm, Sustainable Forestry Initiative, et cetera. And the savvy landowners will understand all of this as a package that maximizes the financial viability of working forests. So here's the integration of carbon and co-benefits that I mentioned. We actually did this. We mapped it. We quantified it in this feasibility study. We started with layers showing forest cover in Vermont. We overlaid on that a map of flood resilience value. This was a layer that the Gund Institute for the Environment at UVM had produced. We took the top 20th percentile of parcels statewide in terms of flood resilience co-benefits, and we pulled those out of the mix. We then layered on top the forest blocks that we mentioned previously. We buffered those by a mile to again look at the potential to buffer forest blocks through conservation, maybe incentivized by carbon projects. And then we put all this together and we calculated that there's about 285,000 acres out there in Vermont of privately owned parcels. So this doesn't include state, federal lands, and I don't think it included town forests, although I'm not actually sure, I don't remember. But it showed that there's this substantial opportunity for carbon projects in Vermont that would have these very real co-benefits of flood resilience and open space or forest block conservation. Again, we've got these maps of these parcels statewide. The color coding shows the various different co-benefits that those parcels provide, and we can blow those up like for the Cold Hollow region and say, yeah, this is what your landscape looks like. These are the parcels that would have the greatest co-benefits were you to do a carbon project on them. All right, I'm out of time, so I'll just wrap up here really quickly. The most recent and the last phase of this project was a demonstration project, now completed in the Cold Hollow to Canada region here in north central Vermont up around Jay Peak. So this was an area that landowners had been working together within for quite some time and gave us that kind of, social capital or potential to come in and then work directly with landowners to build Vermont's first ever aggregated project on the voluntary market, and actually the first large aggregated project that we know of, I think, nationwide. So really exciting that this has now happened. We brought together 10 landowners representing 12 parcels, almost 9,000 acres. We took this through the whole process under the verified carbon standard. The project was registered on the American Carbon Registry, passed verification, and the credits have now been allotted and sold. And this is the way the numbers break down. You can look at the net revenue to these landowners over the first 10 years. So after we've accounted for all these transaction costs that I mentioned that are very high, very steep, very formidable, the net revenue in the first 10 years is this, about 3.2, or by other estimates, about $3.5 million. That is a substantial net revenue that these landowners will now enjoy. And it's important to understand that this is supplementary revenue on top of revenue that they're also gaining from sugaring. Some of these are active maple syrup operations, and in addition to revenue from sustainable timber harvesting and other wood products that are generated. So it works out to be an average of $282 per acre per year in net supplemental revenue generated from this project. Last slide here, just cruise through this. We've learned a lot from this project. We've learned what worked well, what didn't work well. We've learned, what we would recommend that landowners think about in the future if they're interested in developing aggregated projects. And we're now in this position where we can share these lessons with landowners throughout Vermont. I just need to summarize the slide this way because I'm out of time, but I'm happy to follow up with folks if they're interested in learning about these recommendations. Okay, so I'll end right there. Thanks very much for your attention. I'm sorry the talk was so long, but I hope you get the idea of how complicated this field is. Okay, thanks again.
Bill, thank you. That was really excellent. That was tremendous and so helpful. Just so everyone knows, if you do need another crack at that, what we just heard from Dr. Keeton, all of these webinars are being recorded and will be posted on the AVCC website. I'll get to that in the next week or so. Sorry we've run out of time and aren't able to take questions, but I do encourage you to reach out to Bill offline if there are other pressing questions that you'd like to get into. And lastly, please do join us next week for more talk on this theme of caring for the land with Zapata Courage and Lynn McNamara talking about balancing different goals in managing land. So thank you all so much for sticking with us. Have a great day. And Bill, thank you again.
Thanks very much. And I'm happy to stay on for a few minutes if anybody wants to. I don't know, Jens, if you can, but thanks anyway.
Yeah, I'm terribly sorry. I have another one to get to.
No problem.
I apologize.
Thanks very much.
But thank you all.
My
Cheers.
fault. Bye-bye.